Hello, my name is Bomjin Chan. Today, I will introduce an innovative solution to prevent nanoplastics from penetrating crops using graphene technology. This figure shows the plastic waste in the Korea and the Indonesian farmlands. As you can see, a lot of plastic products have been used in the agricultural fields in the various countries. Leftover plastics such as films and vinyls are broken down into the nanoplastic by the physical impacts such as UV radiation. In this way, the nanoplastic in the agriculture field can cause the serious issues. Recently, an Italian research team found the nanoplastic in the apples and carrots. When consuming crops contaminated with the nanoplastics can accumulate in the human body. This accumulation can damage cells, ultimately leading to the health problems. Nanoplastics were often charged. The electrically charged particles move toward the opposite charge. Meanwhile, solar cells can provide electrical energy. My research aims to develop an innovative solution to prevent nanoplastics from penetrating crops. To achieve this, I had to determine whether the materials could be used as non-toxic electrodes. Graphite is the consist of the multiple layers of carbon and has high conductivity of the heat and electricity. Graphene is the single layers of structure of the carbon atoms and also has a flexible conductor. But it challenges mass producing pure graphene. So I have focused on the artificial graphene and developed the film that mimics the graphene. In this study, I confirmed whether the nanoplastic has the electrical mobility, which electrode is optimal for the nanoplastic electrical capturing, how the graphene can be mimicked, and whether graphene mimicking film can be used for the inhibition of the penetration into crops. I prepared a graphene mimicking film called CTCGP or FCGP by coating them the graphene powder into the silicon tape or agar rolls. And then I confirmed the film's the electrical conductivity by the bubble formation on its surface when electricity was applied to the film in the solution. Also, I used the film as electrode to examine the electromobility of the fluorine nanoplastics. Lastly, I tested whether the films with a low voltage prevent nanoplastic in the soil from penetrating into crops. So I planted the lettuce in the potting soil contaminated with the fluorine nanoplastics and applied each filament with the 9 volts. So I examined the capture of the nanoplastics in the soil by the films, the penetration of the nanoplastic into plants in the absence of the electricity, and the inhibition of the nanoplastic penetration into roots by the films. As a result of the checking the electrical mobility of the nanoplastics by using a copper plates, lead wires, or the graphite rods, I confirmed the nanoplastic migrating toward to the positive electrodes. It is noteworthy that the copper plates and lead wires were severely destroyed, whereas the graphene rod remained stable. It means that the graphene can be reused for optimal electrodes. Second, I confirmed whether the graphene vacuum film has electrical conductivity and whether its fluorine nanoplastics have been charged. The results show the fluorine nanoplastics were detected on the surface of the graphene vacuum film. Third, I determined whether the nanoplastic in the soil could be captured by the graphene vacuum film supply electricity. As a result of the observing the film's surface under the fluorescence microscope, I could detect many nanoplastic particles on the surface on the both films CTCGP and the AFCGP. It indicates that both films can be effectively captures nanoplastics. Finally, I investigated whether the electrically supplied film could suppress the penetration of the nanoplastic into crops. The number of nanoplastic in the roots was significantly reduced by the CTCGP or FCGP supplied electricity. Therefore, I showed that the films can effectively prevent nanoplastic penetration into crops. Although the graphene film effectively captures the nanoplastic in the soil prevents their penetration into crops. However, the agarose films were degraded due to soil moisture and the graphene powder was detected from the silicon tape as the time passed. Therefore, exploring moisture-resistant, non-toxic flexible materials and developing a technique to coat them with a graphene powder could enable the long-term use, providing the sustainable solution without the additional costs. Thank you for your attention.